Okay, let's finish our derivation of the countdown problem. We started out with a very simple brute force solution. Then in the second step, we took the generation process and we made sure that we never generate expressions that were invalid. And what we're going to do in this third step is we're going to shrink the search space by leveraging algebraic properties of expression. In particular, the fact that multiplication is commutative and the fact that 1 is the neutral element for multiplication. Okay, so these are the properties we're going to use. Multiplication is commutative, and 1 is the neutral element for multiplication. All right, so here's the previous definition of whether an expression was valid. And remember, an expression was valid when the numbers of which it was composed were positive. So when we added two values, well, that's valid because adding two positive numbers gives a positive number. When we subtract two numbers, the result is positive when the first number is larger than the second. Multiplication of two numbers, positive numbers, is always positive. And here we had to make sure that we remained within the integer domain. Well, in this case, instead of just returning true, what we do now is we say we want x to be less than y. So we're going to make this thing biased. So adding x to y is valid if x is less than y. And we're going to do the same for multiplication. Okay? And now we also want to say that if the x is 1, we don't consider this thing valid. Okay, so we're throwing that one away. So what we did is we biased the representation. We say we always want the one on the left to be larger than the right. And by that, we have eliminated add yx as a valid expression. So you see, this is quite a clever trick. So if x and y are the same, it's still valid. But if x is less than y, less or equal than y, we have eliminated the commutative expression at yx. Good. And then we also want to use the case where x or y is 1. Okay? So this takes into account the commutativity of multiplication and addition and the fact that 1 is the neutral element of multiplication. And finally, also, when we divide by 1, that's the same as x. When we apply this very simple extension to the tests, it has quite dramatic results. So when we look at the solutions for this, there's now only 250,000 valid expressions. Okay? So that's about 20 times less than before. And when we look at the solutions, there are about 16 times less. Because all the solutions that we had were duplicates of each other. Or all the solutions, there were many duplicates in those solutions. So when we run this now, it finds the first solution in 2/100ths of a second. But even more important, it finds all the solutions in under half of a second. So you see, really, all the problems from this TV program are solved within half a second. And we started out with all solutions being about 44 seconds. So this is quite a dramatic improvement. And you see that it was not that difficult. We made two small steps, starting with an obviously correct solution that was slow, and then we refactor it to remain correct but become fast. And this is the way Haskell programmers like to work. So you start with something that's right, and then you make it better. Great. Thank you so much. Happy hacking. Make sure you do your homework, and then see you next week.